My name is Blanki, and I'm a senior web developer at Applitools. So before I get to the main topic of this talk, I wanted to give you some background. So bear with me, and let's do a quick show of hands. Who heard of the term automated visual testing? Nice, impressive. Okay, so visual testing is the act of verifying that your user interface appears correctly to its users. The goal of this activity is to find visual bugs, such as fonts that weren't rendered correctly, or colors, or maybe layout, and other rendering bugs that we want to find before the end user sees them. So lots of variables can affect this and how your web application looks. It might be the web browser, or the operating system, the display size, and other variables. So it makes the nature of visual testing very complex. That's why we want to automate it, and it really pays off, because one automated visual test is worth hundreds of assertions, since it will look at a page and assert that everything was rendered correctly. So at Applitools, we developed a cloud service that provides automatic visual testing. Tests that run against us send us screenshots, and we analyze and compare them so that we can see the visual change. At the end of this process, the best way to show the result is to simply just present the before and after image to the user with all the visual indications and the assisting information. So this required us at the front-end team to develop a very ambitious and complex user experience at our web application. So how do you go about developing an ambitious web application? Well, Ember.js calls itself a framework for developing, for creating ambitious web applications. So that's an easy pick, no-brainer. So that's why our first choice for building such a complex web app was Ember.js. But actually, we had a lot of trouble with it, and we complained a lot. So when react.js showed up, its philosophy resonated with us, so we decided to move to react.js. So now we can complain about react.js. I'm just kidding. We actually really love react.js, and we moved to react.js not long after it was released by Facebook, and since then we never looked back. We're constantly learning and staying updated with the latest features and practices. However, even with React, not everything went smoothly, and that makes sense because no tool is the perfect solution for every problem. So a complex web application such as the one we've developed hit a few walls that we couldn't just pass just by using React.js by the book. So today I wanted to share with you some of these cases and how we worked around React.js within a React.js application. Okay, so the problems and solutions that I'm gonna talk about today are not limited to React.js only. These are obstacles and problems that any web developer might encounter at some point while working on a complex web application. But actually React.js makes it a little bit more complicated to solve. So today, by the end of this talk, hopefully you'll learn a few tricks. You'll learn a very useful and powerful pattern in React.js. And I hope that you'll feel confident with React.js, and you'll know that it can meet all your requirements, and it's flexible enough and contains all the escape hatches that you need. So I talked a bit about what we do in Applitools. As part of that, we provide our clients with tools that allow them to weave their window checks into their automatic test code, so they can see the visual change of their app. They can completely supersede the need of manual testing. So I actually use this ability lately for my own personal benefit. You see, I got married last week. A true story. Thank you. So I reached out to the conference organizers and asked them to change my last name at the conference website. I asked them politely. Just a second. But then I wanted to make sure that they actually did it and that they spelled my new last name correctly. So I ran an automatic visual test on the site, and up until now, I kept seeing my my previous last name. So let's run it again, and going through the entire page and covering all the appearances of my original name. Let's see. Okay. So this is our web application. We call it the dashboard. Here's the test that we ran before. It's called Let's Make Sure Anna is Still Single. Okay. As you can see, it scrolls down the entire page and takes screenshots while it's scrolling. And then it stitches all those screenshots together to create a full page screenshot. Now we check with the dialog. Great. Let's see it appear. Perfect. So now we have the new test. Okay. So the little images that you saw are just the preview of the image. Next, what the user wants to do is to see the full image and to see the visual differences that were made. So the result of this process is that we have tons of potentially very large-scale images. And the images are large because every pixel matters. So we want to keep them in the original resolution as PNGs. So we have to present also have to present them to the user with the ability to drag and pan and to zoom in and zoom out and do other user interactions. Another reason because of the large scale of the images is because what you just saw, we take a full page screenshot. We go through the entire page and take screenshots while we scroll. Great. Wait. Okay. Anybody tried to work with large images before? Nobody? Okay. Whoever tried to work with large images knows that it can lead to a very bad user experience at the client side. So these are the main pain points, sorry. First of all, depending on the connection speed, the download of the image might be very, very long. Then it takes a long time to render the image at the client side. So this is just before we can show the image. It takes a long time. And then we want to enable zooming and dragging and other interactions. Usually we achieve that by using CSS transitions. And it can lead to a very laggy browser, especially when we try to scale down the image on zoom out. Now I wanted to show you what kind of interaction we aim to provide. Okay, here's our test. Let's see it. So this is a small image. We can't see if anything changed here. So we need to zoom in. Let's see if my name changed. Okay, great. We see a visual indication that my name changed. Let's toggle. Great. Let's check here. It changed here as well. So I just want you to notice that we can easily zoom in and, zoom out and zoom in and change and drag the image, and it has to work smoothly and fast. That's our main purpose. Okay. So, after lots of thinking and research, we reevaluated our problem, and we asked ourselves a few questions. First, if the user watches a zoomed out image, why do we need to get the large image with the full resolution? He sees the image in a reduced resolution at first anyway, so that's just a waste of time to get that. And even when the user zooms in, doesn't he see only part of the image? So why do we need the entire image for that? The first thing we decided to do is to download a scaled down image for the zoomed out display. So it's shorter download time, faster rendering, and it doesn't cause browser lagging. The second thing is to download a cropped image that matches what the user sees right now. Again, shorter download time and rendering and less work for the browser. So all we have to do now is to somehow accumulate all those images together to show them together as one image. To achieve that, we chose to use a canvas element. At first, we download a low-scale image and put it on a canvas that fits the page size, okay? We create few more canvases that are, at this point, they are hidden. We create them in the memory, and each one is designated for a specific scale level. When the user zooms in, we copy the image from the smaller canvas to the bigger canvas to fill any blank spots. At this point, the image will look a little blurry, as you can see, because the image is stretched to the bigger canvas. We calculate the dimensions of the region that the user now sees, and we get the cropped part of the image in the better resolution, as you can see here on the slide. So then we continue to populate the canvas with the higher resolution as the user drags the screen, the canvas. So another optimization that we made, we keep the canvases per scale level in the memory so that once we drew the image parts, we don't have to do so again. Every time the user drags this around leads to populating the canvas with image parts that are downloaded from the server. We switch canvas when the user changes zoom level, okay? The resolution of the images, image parts is according to the zoom level. So that's another optimization. If an image part of a certain scale is required and we detect it is contained in a higher resolution canvas, we can just take it from there. We don't need to get it from the server. So we were happy that we could find such a solution, but we quickly realized that it's not something that React was built for. So to understand the problem, we have to take a moment and talk about imperative programming versus declarative programming. So imperative programming is a necessity. It will always be there due to the simple fact that that's the only kind of control that the computer understands. Working imperatively means that you tell the API that you use what you want to do, and you're concerned with how to achieve that. Okay, so this work can be very tedious, so thus abstractions were made to save you the deal with the how and let you focus on the what. Okay? For example, when I was single and I wanted a cup of coffee, I told myself, Anna, let's get a cup of coffee. So I went to the kitchen and boiled water and got a cup, put instant coffee, 1 spoon of instant coffee and 1 spoon of sugar, 80% water and 20% milk, and voila, I had the coffee. So now I have an abstraction. I just tell my husband, honey, I want a coffee, and I get the coffee. Simple. So some people believe that React is a framework because of the inversion of control taking place when React renders your custom elements to the DOM. That's how React lets you work declaratively. Okay, you tell React, I need a div with certain properties, and React renders it for you. It's React's job. You don't actually go to the DOM, find the future parent by means of class names and IDs, then create a div element and append it to the parent. React does that for you. So it abstracts all these details from you. But as is the case with most abstractions, sometimes you want to break through the abstraction. What's great about React is that it lets you do it by design. So you're using a legitimate workaround. Before explaining the solution, let's take a moment to understand the problem in more detail. A React app is rendered below a DOM tree, a DOM node, that serves as the root of the application. We write custom components that return a description of their node, given their current state and properties. Then the components are composed together to a tree, starting from the root. Upon state change, React travels the tree recursively and uses the description returned from every component to create a virtual DOM. Okay? After the virtual DOM is created, it is compared to the formerly built virtual DOM tree, and the one that matches the current real DOM at this point. React tries to find the difference between the current virtual DOM and the previous virtual DOM. And this diff is the only actual change that is made to the real DOM. Okay? This work mode is the main reason of React's speed and its ability to provide us with a simple mental model to plan our app. A few things to note though. When it comes to the DOM that React manages and manipulates, any direct manipulation that we'll try to do on it will make React freak out, as it won't be able to properly apply the computed diff. React is the one that's generating actual DOM elements. It expects the user only to describe them, not to render them, not to provide them. Even if a React component was re-rendered, if there's no diff between its representation in the DOM and the new virtual DOM tree and the old virtual DOM tree, no change will be made. It's not written to the DOM, okay? So now we can understand the problem and the solution. For the solution, we used a very, very powerful pattern that is called the portal. The basic idea is as follows. You write a React element that only renders a div. React renders this div for you. Use a ref to this div to directly manipulate everything you need from this div down. Okay? In other words, this div is the root of your non-React subtree. You hide the DOM manipulation from React by using an empty div. You use the component will receive props method to allow yourself to receive updates and apply them manually. If you need to render React child elements, you do it by starting a new React root. Okay, now let's see some code. So as I said, we start by rendering an empty div. we render nothing else here, so that the DOM diff mechanism will never try to do anything to this again. And we are left with the DOM node to mess with as we would like. Next, component did mount is the right place to grab a reference to this node right here and do whatever direct work we need to do with it. Here you can also create a new React tree to render the children if needed, like we do right here. Okay. Component will receive props, allows you to connect the React app to your component. This is the place to manage all the updates. Okay. Component will unmount is the right place to do all the cleanup that you need, like clearing your canvas cache. So this is the pattern that we use to solve our problem, and it worked great for us. This way we were able to work imperatively inside the React app and to isolate the manually manipulated component in a way that React is unaware of all our DOM mutations and leaves us to it. We created a complex and we created a complex and optimized component of a large image viewer with it. Based on the cached canvases, and we integrated it to our React.js app. The beauty of all that is that rest of our React app is unaware of is unaffected of all this workaround. This pattern is very powerful, and it can fit more than just this case. For example, it's also great for integrating with third-party libraries that perform direct DOM manipulation, like jQuery UI widgets, for example. So to conclude, I assume that this crowd consists of both veteran React developers and new React developers. When I sat down to write this talk, I tried to think how I can contribute to both kinds. I think that developers that are new to React or that are betting on React for the next project should feel confident with React right now. Okay, so I showed you an advanced app that was completely developed in React.js. Okay, I showed you an implementation that, in a way, is the opposite of how React wants you to work, and it still can fit nicely into a React app. This is an indication of React's flexibility and its ability to support each use case by design. So we saw a pattern that can allow us to gradually migrate existing components into a React app. We also talked a bit of React's inner workings. I hope that developers with more experience with React also learn something new, whether it's the technical difficulties of, and considerations when we are working with large images, whether it's the options for optimizations of such use cases. It's a good chance that the portal pattern is news to some of you. It's nice to know that we can integrate widgets from the enormous ecosystem of jQuery and other DOM manipulating libraries into React. I also hope that all of you saw the power of automatic visual testing. And I recommend every front-end team to make it part of your development life cycle. Thank you so much.